So now that we have generated random numbers, we've set the seed value to different values, and we've modified the range of values returned, let's look at a few more things. First of all, are random numbers really random? You may have picked up on my saying that different seeds are going to give us a different pattern of values. Well, our computer is using an algorithm to create random numbers. It's a complex mathematical equation, but it is a formula, and whatever number is used as input to that formula is going to influence the output. And the random number generator that we've been using, and a lot of common ones, are called PRNGs, or pseudo-random number generators. And we say pseudo-random because they act like they're random numbers, and they'll look like they're random numbers, but they aren't truly random. No algorithm can be truly random. We're doing calculations with formulas. We want to create an algorithm that looks like it's random. And the two goals that we're looking for here are, I want uniform distribution. That means each number is equally likely to be chosen. So if I throw that die 600 times, I would expect to see in real life each side 100 times. That's what I want to see with my random number generation. Now, if I threw a die 600 times, I might not get exactly 100 times for each side, but I would get something very close. And I want to see that with my random number generator too. The other thing is something called period, and this is the length of the sequence until it repeats. So if you call the rand function enough times, eventually you're going to get to the beginning of the sequence and you'll see the same sequence of numbers. Now, it's going to take a very long time, and that's another one of our goals. We don't want it to look like it's a pattern. So what we've been looking at are pseudo-random number generators, but what else is out there? We worked with the rand function. A lot of modifications were made to the language with the C++11 standard, and they added a new random library. And when you want to use this, you'll include the random library with the random header file name, and it has better generators than what we're seeing with rand. And so there are a number of different algorithms. One algorithm that is fairly well respected, the Mersenne twister algorithm, and please pardon my French pronunciation on that. It has to do with some mathematical things that were developed by different mathematicians. They also have in this library other types of distributions. So I may have a situation where I don't want a uniform distribution, and there are some things in the new random library that I can use if that's something I'm looking for. So let's review what we've talked about here. First, which two header files are needed for random numbers? The first one I talked about was the C standard lib, and that's what I need for the rand function. We also use the ctime header file or library in order to get the system time as an input for the seed. Why do we often add 1 to the result? Well, the modulo operator is going to return values from 0 up to the divisor. A lot of times we're looking for a range of values that are 1 through something else. And so we'll take the result that we get and we'll add 1. Now, if I want to generate 5 random numbers, how many times do I call srand? That's the function I'm using to seed my random number generation. And we only want to call that 1 time at the beginning. And then finally, If I want to write a statement to get a random number between 1 and 10, how do I do that? I'm going to call the rand function. I'm going to use mod 10 because that's the number of values I have, 1 to 10. And then I'm going to add 1 to the result. Now you may have noticed here I put parentheses around the beginning of this expression with the mod operator. And really those parentheses aren't necessary. That's more just to make it look more obvious about what's happening. The modulo operator has precedence over addition, so it will occur first without the parentheses or with the parentheses.